I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 7th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Niño, weather analysis, real data for outdoor people, all the time, no hype. Welcome back. I'd like to take a minute to thank everyone I've seen over the past couple of weeks. People come up to me all the time and say, thanks for doing the videos. Good to see you in person. I see them out in the water surfing, whatever. Give me suggestions, give me ideas. I really want to thank everyone for doing that. It means a lot to me, and I appreciate the compliments and all the good words. All right, let's get to work. As usual, we'll start by looking at significant wave heights over the North Pacific Ocean. We see a small area of seas, maybe 12, 14 foot, something like that. Part of a fetch that developed over the weekend. Again, nothing really impressive at all. It generated wind swell pushing into the California coast on Saturday, and then into Sunday, and maybe a little bit more is expected on Monday, but not a whole lot from it. Otherwise, a pretty calm pattern is in play. As usual, start by looking at winds at the jet stream level. These winds up about 30,000 feet help support formation of gales when they form, help direct their track. We're looking for a dip in the jet. We see a little bit of one right here over the northeast Pacific. What that helps to do is create a counterclockwise flow aloft and down at the ocean surface, and that's the hallmark of low pressure. That is wind rotating counterclockwise around a deep core of low pressure. That generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough as they radiate away from the fetch area, turn into swell. And swell, when it arrives at your beach, turns into surf. Right, so we have a little area of interest here, a little bit of a trough in the northeast Pacific, and otherwise, not a whole lot going on. Notice the jet is split over Japan. It sort of organizes, consolidates here in the west Pacific, ridges a little bit. That means moves up to the north, and then falls into the Gulf, creating our trough. All right, as we get into Monday, much the same pattern sort of occurs. A little bit more wind energy starts building in that trough, maybe amplifying it a little bit by Monday night. Also notice a new trough starts building over the dateline as we get into Tuesday. 12Z Tuesday, that's Tuesday morning. We are now on standard time, so that would be 4 a.m. California time. Subtract 12 hours from that, and you get California time. All right, winds, first a little trough here in the northeast Pacific on Tuesday, but a broader trough over the North Dateline region on Tuesday, maybe supporting gale development. That pushes west into the western Gulf on Wednesday, continuing on Thursday, then starts to pinch off a little bit as we get into Friday, but it's entirely possible there could be some degree of swell generation during that entire window, and then the trough pinches off, does nothing to help support gale formation anymore, and we kind of have a mess of a pattern until we get into Sunday. That's a week from now, and I don't know if we even believe it, but a little trough starts carving out again over the North Dateline region, trying to develop. We'll see what happens. Just not a lot of wind energy in the jet stream lately. The pattern really has kind of fallen apart, at least in upper levels of the atmosphere. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, and as expected, a completely placid pattern. No real significant low pressure systems at all, like a 1004 millibar low there, and like there. None of those are deep enough to generate any meaningful winds, and therefore no meaningful fetch. Now, theoretically, as we get into Monday, a gale starts building here off the U.S. West Coast. Little bit of winds. There, at one point, this was supposed to be an atmospheric river event, kind of a big deal for California. Looking to be a lot less now. Yeah, some precipitation, maybe some wind, but not a whole lot. As we get into Tuesday morning, a little fetch of 45 knot winds right up here. It's developed off the British Columbia coast, barely in the North California swell window, like 315, 317 degrees. By Tuesday morning, it's inland and fading. Another little gale, very weak, starts developing over the North Dateline region with 35 knot winds falling south, maybe producing something aimed at Hawaii. And then that too sort of fades, moves back to the far east or northeast Gulf, and maybe something will try to develop from that on Friday. But again, very north angled relative to California. And then we just go out and really a little cutoff low maybe here north of Hawaii on Saturday night and Sunday. And then potentially a broader gale developing over the North Dateline region as we get into Sunday and Monday a week out. But any model that's predicting something a week out is not worth believing at all. So take that with a grain of salt. All right, let's move on. Let's go take a look at the effect of these winds on the ocean surface. And here we go, significant wave heights for the North Pacific Ocean. Also, there's really, normally we go into a hindcast model here, look what's happened over the past 4 or 5 days, look for any swell that is in the water radiating towards either Hawaii or the U.S. West Coast. Unfortunately, there is literally nothing, so we're not going to do that. We'll look to the future and keep our fingers crossed, hoping that something will materialize. And as expected, as we get into Tuesday, a little bit of a gale here in the far northeast Gulf, developing 27.2 foot seas to be exact. The highest seas over this entire domain are listed right there. The maximum winds generated to produce those seas right here, 54.1 knots at roughly the same location. So maybe some hope there, but pretty fleeting and short-lived. Another gale, again, we saw that, generating 21-foot seas or so, falling south, targeting Hawaii. So a little bit of a swell there. And that fades out, potentially trying to redevelop in the northeastern Gulf, but as you can see, maybe only 18-foot seas at best on Friday night. And then after we get into that, another cutoff low, 20-foot seas targeting Hawaii on Sunday. And then potentially some other sort of gale over the North Dateline region, but still rather unsure as to whether that will happen at all. Also, there is some small southern hemiswell working its way up towards California. And we're going to say mainly for southern California. Size pretty minimal, like 2 feet at 16 seconds. And I believe that's a Tuesday, Wednesday, Thursday sort of event. Look at the quick cast. You can get it there or in the detailed forecast on Stormsurf.com. Looking out mainly at local weather relative to California and Hawaii and winds, kind of a weak pattern on Sunday. A little bit of northwesterly winds along the central California coast, but nothing too intense. So we get into Monday, that pattern weakens as a new gale starts building off the coast. Also trades pretty light for Hawaii. So we get into Tuesday night. You can see the front queuing up off of Cape Mendocino in Northern California, 35 knot south winds, and that impacting the coast late in the evening up there, maybe even 40 knot winds, and 30 knot winds into the San Francisco Bay Area, maybe down into Monterey Bay. But by sunrise on Tuesday, 12Z, that already pretty much over the worst of the front through, some sort of degree of northwest winds quickly fading as we get into Tuesday. Trades continue for the Hawaiian Islands. Wednesday, pretty northwesterly wind pattern, light winds. You can see this small, weak, high pressure ridging into the North California coast. So light winds there, but south of there, northwest winds, probably 15, 20 knots. Trades again for Hawaii. Thursday, pretty much repeat of the same pattern. Friday, again a repeat, though the high pressure lifting more up into the Pacific Northwest, so more north winds for a larger expanse of Central and North California. Saturday, same sort of deal, just weak high pressure. Then the cutoff low north of Hawaii, generating perhaps something there. Northwest winds start fading for California as we get into Sunday, and just pretty much not a super energetic pattern other than that one front that we were talking about that's coming in Monday night and Tuesday for California. Precipitation. We're looking at California. Every drop counts. We'll take it. We know there is a front building. Here you can see it right off the coast on Monday, 0Z. That would be at 4 p.m. on Monday night. The front pushing in down into Monterey Bay about 10 o'clock in the evening. and then on with snow into the mountains as we get into Monday night and Tuesday morning. But by about midday Tuesday, even that clears out. Maybe a little bit of rain up in Cape Mendocino as we get into Wednesday and Thursday, but high pressure ridging into the coast, pretty much setting up a dividing line. You can see it right there between wet up north of that line, we'll call it southern Oregon, and dry south of there. And that's pretty much the theme for the rest of the week. We're into Saturday here, nothing. And then as we get into Sunday, even more so, the ridge starts pushing north. So a cold front for the early part of the week, high pressure and a ridging pattern taking over for the rest of the week after that. We'll do a quick run here for snow for, we'll say the entire west U.S. coast, but you can see most of the action will be up into the Pacific Northwest and British Columbia. A little bit here as we get into Monday evening, into Tuesday morning for the Sierra, and then clearing out pretty quick, and then that's pretty much it. We'll roll through this. This is a 10-day model, so you can see, again, Pacific Northwest getting the lion's share of the snow and the precipitation, and even a little bit more as we get now on Tuesday, a week from now, or a week and what was that, 9 days from now, maybe another little front. But again, do we believe the model's that far out? Certainly not. Snow dashboard for Squaw Valley or Olympic Valley, what's that, about 9 inches, all in that one Monday night, Tuesday morning window, and that's about it. Snow level's probably pretty high, and the precipitation moving through pretty fast. You can see, in fact, here's the snow levels. They're not bad at the moment. Snow level, or the freezing level, is about 6,500 feet, toggling somewhere in between the 7,000 and 8,000 foot range when the precip comes through, and holding for a day or so, but then moving back up to 12,000 feet as we get into late on the 10th of November and pretty much beyond that. It's still really early in the year. You know, typically to see snowfall, skiable snow even at Thanksgiving is kind of a big deal for the Sierra, and we're weeks from that still. So, and there is snow in the mountains, not a lot of Olympic Valley shut down because there wasn't enough coverage, and that's not really surprising. We were kind of hopeful there for a little bit that there'd be a second atmospheric river event, but that has since faded from the charts, so we're going to have to make do with what we have. At least the fire danger is heavily suppressed. All right, let's move on. Long-term outlook. What's going on with the Madden Jullian Oscillation? A periodic weather oscillation that revolves around the planet. We'll get into that. And, of course, the El Niño Southern Oscillation. These two oscillations really dictate weather for the Pacific if you're looking out a month to up to 3 months out. So the MJO comes in 2 phases, the active phase and the inactive phase. The active phase is the one that we're looking for. When that moves over the Pacific, it helps reverse trade winds, feeds energy to the jet stream, which then in turn feeds the storm track, which then of course generates surf. And then it also can create Kelvin waves, that is, take warm water that's balled up in the West Pacific and push it to the east. The MJO, Madden Jullian Oscillation, comes in 2 flavors, active and inactive phase. The active phase is on one side of the planet, the inactive phase is the other. They rotate around the planet from west to east, right? And when the active phase moves over on the equator, right? Moving west to east on the equator. When the active phase moves over the equator in the West Pacific, that feeds our storm track, like I said earlier. When the inactive, and it takes about 5 weeks to make it across the Pacific, then the inactive phase follows behind. And when that happens, it does just the opposite. It enhances trade winds. It sort of steals energy from the jet stream, which is exactly what's happening right now. And then and it also creates high pressure over the Pacific, and that sort of dries things out. All right, so we're looking for signs of either the active or the inactive phase of the MJO. This is data from the TAO buoy array, series of buoys strung across the equator, used for monitoring El Nino. This would be the West Pacific here. This would be the East Pacific here, like near the Galapagos, Ecuador. And this is the West Pacific here. That's New Guinea there. 0 is the equator. The date line is right there. The colors are water temperatures, and as you can see, a bunch of the sensors, so the buoys are stacked up. I think there's like 6 or 8 of them on either side of the equator, every 15 degrees across the equator. So quite a bit of hardware thrown at this. They're anchored to the bottom of the ocean. There are sensors on top of the buoys for measuring wind. Now, it's not like hourly wind like you used to from the NOAA buoys. This is more average. I think it's 5-day average, or means as they call it, average wind speeds. But you can see from the length of the arrows how strong the winds are and what direction they're coming from. So out of the east, pretty strong, not super strong, but we'll say moderate strong over the East Pacific, moderate to strong over the Central Pacific, and moderate to strong over the West Pacific, the Kelvin wave generation area. This is the area that when the active phase of the MJO moves over this part of the Pacific, it can reverse trade winds, and not only does that feed energy to the jet stream, but it can take normally warm water that's here that start pushing it to the east, under the equator, the whole way across the Pacific, and eventually that warm water will impact Ecuador, start gurgling to the surface, warming sea surface temperatures in the far East Pacific, and that's known as a Kelvin wave. Successive Kelvin waves, if you get successive active phases of the MJO, that can help kick off El Nino. Clearly, we're not in any state of being like that anytime soon. All right, but it's not the average wind speeds that matter. It's the anomalies, difference from normal for this time of year. Looking at the arrows, there literally aren't any. There's some here, they're out of the west. So we'll say the winds in the East Pacific are actually a little bit weaker than normal. That's kind of a good thing. Over the Central Pacific, pretty much normal. But you see these persistent arrows here in the West Pacific. That means stronger than normal trades in the West Pacific, and that would typically suggest the inactive phase of the MJO. Let's dig a little deeper. All right, the 7-day forecast. This is the whole planet on one chart, and we're just looking at the east-west component of the wind. Is the wind blowing stronger out of the east or out of the west? The blues are easterly anomalies, and easterly anomalies are synonymous with the inactive phase of the MJO. The reds are westerly anomalies, associated with the active phase of the MJO. So let's get oriented. 180, that's the date line, so it runs right up the middle of the chart. So one can say, and the West Pacific starts about 135 east, so right here, so that'd be like the Philippines and as far over there as you could go. And then Ecuador and the Galapagos, about 80 west over here. So the area we're interested in, though, is the West Pacific, the Kelvin wave generation area. So from 170 west to about 135 east. And this is the forecast starting from this line on down. Now you can see past history here, it's just been persistent easterly anomalies. There's not even any hint of any active phase MJO activity at all over the West Pacific in the Kelvin wave generation area for months now. So that's a pretty good indicator that La Niña is in control. And you can see, if anything, east anomalies building to strong status today, holding through about the 11th or 12th of November, then maybe starting to phase out. But for right now, it certainly looks like the inactive phase of the MJO is in control. No surprise, look at the jet stream, look at the storm track. Everything's just kind of evaporated and we're dead right now. No significant air movement, so that would make sense. So let's go look 2 weeks out. So this is a chart that depicts outgoing OLR, outgoing long wave radiation. Fancy words for cloud cover. The active phase of the MJO is like a low pressure system. So with low pressure systems, typically you have clouds. So the more clouds you have, you'd get what they call negative anomalies, basically less sunlight bouncing off the ocean. So that would be the blues. The yellows are the inactive phase of the MJO, more sunlight, less clouds bouncing off the ocean surface. So this goes out 15 days. This is the current panel, 5-day, 10-day, 15-day panel, all this data from the statistic model. Okay, and let's get oriented. South America, Central America, Hawaii, New Guinea, so 180, that's the date line right there. the equator right there. The area we're interested in is this, what we call the Kelvin wave generation area. That's where when the active phase moves over here, not only can it generate Kelvin waves, but it also does the best to impart energy to the jet stream. So today, not a whole lot going on. Weak inactive phase of the MJO in control. The active phase over the maritime continent, like Bali, like right there. Okay, but 5 days from now, active phase of the MJO supposedly starting to move into the West Pacific, building 10 days from now, and building even stronger 15 days from now. So that looks positive. Let's go take a look, though, at the dynamic model, the GFS ensemble model. It suggests, yeah, the active phase moving into the West Pacific, but very weak, not strong, probably not having a whole lot of impact. The net result, it appears that La Niña is just completely stomping on the active phases of the MJO and killing them when they try. So the core of, we'll get into this a little bit more, but the core of La Niña is like out in here somewhere. And so the active phase of the MJO tries to move into the West Pacific here. It interacts or gets destructively interfered with by La Niña. And it basically, La Niña just cuts the legs out of the active phases of the MJO and renders them impotent. You know, they just can't do anything. So that appears to be what's the case, at least for now. Here's some phase diagram information, just another way of looking at the MJO. Same model, statistic model here, dynamic model here. The MJO moves from west to east, from the Indian Ocean, over the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Okay, the heavy dot is where the active phase is right now. So the maritime continent, let's say Bali, that area. Okay, these are the three different forecast tracks for the active phase of the MJO over the next 2 weeks. And the further the track is out here, out towards the edges of the image, the stronger the active phase is. So 2 members suggest very weak moving to the West Pacific, but 1 member of the statistic model says a moderately strong active phase moving to the almost to the West Pacific. The dynamic model, though, sort of sides with these 2 statistic model runs, just showing the active phase very weak, noodling around, not even quite making it to the West Pacific, and extremely weak. So no real hope there either. The upper level model shows areas favorable for precipitation. The greens are favorable for precipitation, so they would equate with the active phase of the MJO. The yellows, areas not favorable for precipitation, the inactive phase. So what are we looking at? We've got 8 different panels, each over a 5-day period. South America, Central America, zero's the equator. Dateline roughly right there. And there's New Guinea. So the area we're really interested in is sort of right in here. We see yellows and oranges today moving into Central America. So that's the inactive phase of the MJO, moving out of the Pacific. The active phase moving into the Pacific on the 17th of November, let's say, and making its trek across the Pacific through about December 7th. And pretty weak, not super strong. And then a stronger inactive phase setting up as we get into December 2nd and moving across the Pacific through the end of the model run, December 17th. So our window, if there was a window for gale development, it would probably be from, we'll say, mid-November to maybe early in December, something like that. Then the 4-week CFS model. All right, so again, the whole planet on one chart. 180, that's right up the middle of the chart. That's the date line. So the far West Pacific, about 135 east, so over here somewhere. The Kelvin wave generation area ending about 170 west. So this is the area that we're really interested in, right in here. The solid contours are the active phase of the MJO. So an active phase of the MJO, today, this run was November 6th, day behind. The active phase of the MJO proceeded across the Pacific from late September into early, through October, into early November, and it is gone and out of the Pacific now, this solid contour. And you see even the reds are westerly anomalies, the blues are easterly anomalies. Even with the active phase and westerly anomalies, they made it almost to the date line, and just once they hit the date line where the core of La Nina is, they just dissolved. And then once they made it back over into the East Pacific, the westerly anomalies reappeared. This is a classic example of that, what they call destructive interference from La Nina on the MJO. So here we come then. Next up, the inactive phase, this dotted contour here, moving across the Pacific. Now, it constructively integrates or interferes with the La Nina base state, because La Nina is effectively like a long-running inactive phase of the MJO. So they team up, they're in phase, and what's the result? Stronger than normal easterly anomalies forecast for now through, well, the whole way down to about November 23rd or so. So that would probably be a window not particularly favorable for storm development. Now you see the active phase of the MJO right here in these westerly anomalies trying to slowly work their way into the West Pacific as we get into the early part of December. The question is, will they make it? Or will they get stomped on just like this active phase here? My guess is that will probably be the case. La Nina will trump everything. So if a month didn't lead us to an answer that we wanted to see, to the answer that we need to see, then we'll go look out 3 months. The CFS model going out 3 months. Past performances in the bottom. Future forecast here at the top. Let's orient ourselves. 180. Again, whole planet on one chart. And this is the blues are easterly anomalies. The yellows are westerly anomalies. So you go right up the chart here. And that's the date line. Kelvin wave generation area roughly in this area here. All right, so today, let's get us right in the center. The dotted contour is the active or the inactive phase of the MJO, and you can see it's moving across the dateline region today with blues creating easterly anomalies, right? Okay, then the active phase of the MJO is forecast pushing into the Kelvin wave generation area, like November 17th, and continuing through to in the Kelvin wave generation area to maybe, let's see if where is exactly about right there. So into about, Christmas time, something like that. With yellows, westerly anomalies supposedly developing and in the core of the Kelvin wave generation area. Now this active phase, we've been waiting for this for 2.5 months. And 2.5 months ago, it was a lot stronger. The closer we get to it actually happening, the weaker it gets. But still, some sort of westerly anomalies are forecast. So this would be a pretty good red X for some sort of gale development. Okay, and then following after that, the red dotted contours, another inactive phase of the MJO. Now, this black dotted contour, we talk about this a lot. The high pressure bias and the low pressure bias, okay? Basically, the La Nina indicator and the El Nino indicator. Right now, high pressure bias with two contours in control over there's the date line right there, right smack on the date line, and forecast to hold, maybe easing off to the east a little bit as we get into January and February. And here is the El Nino indicator. It's over the Indian Ocean right now, so that's, of course, generally low pressure will be focused there, and Indian Ocean, that's where it was last summer, and that's where it still is. But the leading edge of this is supposed to start seeping into the, right here, about 135 east. So let's go right about there, maybe about mid-December, start working its way into the West Pacific, pushing the inactive or the high pressure bias off to the east some. Not sure whether this is going to happen or not, but if it were going to happen, it would probably be in the late January, early February time frame. That's typically when you have these transitions from either El Nino to La Nina or La Nina to El Nino. So maybe there, or maybe we'll just transition into a neutral pattern. That seems the more likely outcome. And just a quick look here, this is the strength of the active phase of the MJO mapped out, not anywhere where it is on the planet, just the overall strength. We've been in La Nina, well, all of 2021, and it started last year. You can see weak active phases, never much reaching above 2 on the scale here, and continuing, except a little bit, this pulse here back in, when was that? June or May. That actually created a Kelvin wave and warmed us up last summer a little bit, but now it's back to the low threshold. Just to contrast that, look back in 2015 when we were in El Nino. You see the massive spikes comparatively of the active phase, a lot more energy in the active phase of the MJO, and then even a little bit in 2018 as well. But since then, it's just been complete crickets. So let's dig in a little bit more deeper into the La Niña state configuration. What's going on down in the ocean, down at depth? Right, this is the East Pacific here, this is the West Pacific here. Data from the TAO buoy array, that same series of buoys used for monitoring El Nino. These little X's here, these are sensors on the anchor lines of the TAO buoys. About every 15 degrees, they're there. Right here at 140, this array appears to be out, and we're sure that there's supposed to be something here at 150 east, and it's completely out too. You take the data, NOAA does, run a model, it gets temperatures at different depth and then fills in the gaps, so you get a profile of where the warm water is, where the cold water is. The 29 degree isotherm has shown back up just a tiny little area. So this is centigrade, 29 degrees centigrade, but a little bit right here in the far West Pacific. The 28 degree isotherm, pretty much steady where it was last week, 175 east. The 24 degree isotherm, I think it had actually pulled back to about 138 west, now easing a little bit off to the east, but notice there's no sensors right here, so it's purely a guess by the model at 134 east. But it is not the temperatures, it is the differences from normal for this time of year, the anomalies. All right, and you see warm water, 2 degrees centigrade above normal, and it was pretty much cut off where it was 160, so 155 I think is where it was last week. So right about here. Looks to be moving off to the east, but again, the sensors are all out here, so I don't know that I believe that at all. And then temperatures last week were 2, 3, 4. This is 4 degrees below normal. Last week, I think it was 5 or maybe even 6. So supposedly a little bit of warming here, but still cold water pretty much taking over the East Pacific. Warm water confined to the far West Pacific. Typical La Niña kind of pattern. Here's another model of the same, using some of the same data, but then data from other sources, pretty much painting the same picture, but showing the warm anomalies. What is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, average probably about 2 degrees. That's consistent with what the other model showed, making it to 160 west, but no further. The other model was saying 150 west. You almost it gave you the feeling like this is exactly what a Kelvin wave looks like. Warm water moving off to the west, eventually reaching the East Pacific, but we don't think it's moving at all. It's locked in place. Massive cold water right here, like 5 degrees below normal, right off the end of the scale here. Locking down the East Pacific. Classic La Niña kind of pattern. Sea level anomalies, another way of seeing what's going on at depth in the ocean, but you're not measuring absolute temperatures. What you're doing is you use the Jason get you right there. Yeah, get the Jason 3 satellite, rotates around the planet, polar orbit. It measures the height of the sphere of the ocean. Take out the waves, strip out the wind waves, strip out the tides. Is the sphere of the ocean surface higher or lower than normal? And especially on the equator in the Pacific, that's what you're really interested in. You see this minus 20, minus 25, orientation, sorry, equator right there, dateline right there, South, Chile, Peru right there, Central America, here's the Yucatan, Baja, California, Hawaii right there, Philippines there, New Guinea there. All right, on the equator, right, off of Ecuador, right smack in the East Pacific, equatorial Pacific, minus 25 centimeter anomalies. Okay, that means a divot on the ocean surface. Cold water at depth contracts. That could create a divot on the ocean surface. Strong east anomalies blowing across here could take water from the East Pacific, push it to the west, creating a divot there as well. Notice the 10 or 20, whatever that is, 25 centimeter anomalies over here, meaning warm water at depth, which expands, which creates a bump on the ocean surface, and also the easterly anomalies nuking, pushing the water that was here off to the West Pacific. So it's just all sort of balled up over there, waiting for the trades to collapse, and then it'll all come swishing or swashing back to the east. That is what will happen when La Nina finally decides to give up, and that could be a sign of a pending El Nino. But as of this moment in time, we see none of that. Trades are stronger than normal, and cold water at depth, and the below normal sea heights here all are strong indicators of a second year of La Nina. A little bit of past history over the past year. Upper ocean heat anomalies. This is the upper 300 meters of the ocean surface. East Pacific here, West Pacific here. Back last December, look at the warm water building into February and March in the West Pacific, while cold water was here in the East Pacific. La Nina in control. And then it was this past spring, March, April, May, westerly anomalies. The active phase of the MJO woke up. Warm water started swashing back to the east in the form of 1 Kelvin wave, a 2nd Kelvin wave in the May timeframe, a weaker one in the July timeframe, and then all of a sudden the warm water was tapped out. Now here we are, warm water starting to build up again, but a much broader area of cool anomalies at depth, suggesting a stronger La Nina, at least at depth this year as compared to last year, and if anything, hanging on longer. Here was last year. There was cold water. It ran off the end of the image here, but it was the equivalent of about that much compared to how much volume of cold water is at depth today. Sea surface temperatures. Now, things aren't quite as bad here as they would look down at depth. And a bunch of the imagery that we normally use, the site that provides it is out today, so we can't do that. But for our purposes, 90% of what we need to see is right here, right now. All right, so this is sea surface temperature anomalies, the difference in temperatures from normal for this time of year. South America, Central America, California, Hawaii, the equator right there, the dateline 180 right there, Kelvin wave generation area off in here. The obvious thing is cool. The blues are cooler than normal, the yellows are warmer than normal. The core of the cool water on the surface, and that's what really matters. Now, the cool water at depth is like somewhere right down about here, but most of the cool water seems to be from about that point on out to the dateline. You call this a westward displaced La Nina. The cold water really isn't like up against Ecuador, and that's good, okay? And warmer than normal water under Mexico, on the equator, out to about a point south of California. If this was a classic strong La Nina, you'd see cool water the whole way into Ecuador, but we see some, but not as much. Where the cool water is typically where high pressure parks itself over top of. So if you're going to say, okay, if there's going to be a high pressure thing, it would probably be like right in this area, but it's not directly over California, or at least that's our thought. That's what allowed that first atmospheric river, what was it, a week or two ago, to come through, and it's been allowing this steady. You can actually see, so that you go, well, there's cold water here in the Gulf of Alaska. That's driven by storms, persistent gales that have been dropping down through the Gulf, suggesting the jet stream is doing, on average, this sort of pattern, coming off Japan, ridging over the dateline where high pressure is, and that warm water there, that would be right under the core of the high where there's literally no wind, so you get maximum sunlight warming the ocean surface. And so the low pressure systems go up here into the Bering Sea, track down into the Gulf of Alaska, creating a bunch of mixing and cooling water temperatures down. So this is a reflection of what is actually happening not only at the jet stream level, but at the surface level, and you can sort of follow the storm track this way. And that is pretty much in sync with this cool water the placement of the high pressure bias that we looked at earlier, all that, like right in here, suggesting a westward displacement, Madoki La Nina. They have Madoki El Niños. Typically, the strongest El Niños, the most warming is right in here, okay? But when the warming is more out here, that's considered a less strong El Nino, or in this case, a less strong La Nina than normal when they're westward displaced. And that actually, at least, bodes in California's favor in terms of precipitation and hopefully snowfall as we get deeper into winter. Actual sea surface temperature anomalies, the index over time. Today in the Niña 1.2 region, so this is the area right up there along Ecuador and the Galapagos, kind of a noisy area. Temperatures 999 thousandths below normal, so 1 degree below normal. And you can see the trend has been steadily downward, but not super strong. Still, too cold. It's certainly not positive. You really want to see temperatures warmer than normal in this area if you want a good active rainfall season, but maybe not as cold as they could be. The official El Nino monitoring region, the Niña 3.4 index, this is the area from on the equator south of California out to about the dateline. Temperatures have been steadily dropping. They got down to about 1 degree below normal a week ago, but today are up 752 thousandths of a degree above normal, 3/4 of a degree above normal, actually warming some. Again, sort of giving you the sense that though temperatures are really cold at depth in the ocean, at the surface, not as bad maybe as they could be. And so that's a good sign. Any bit of warming is good for helping precipitation and for feeding any bit of energy there is into the jet stream. We'll take whatever we can get. And then finally, one last indicator, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific. When pressure is lower in Tahiti, then the index goes negative. That's what we would want to see. That would be driven by either the active phase of the MJO or, of course, El Nino. When it goes positive, like it is today at 17.05, probably a sign of either La Nina or the inactive phase of the MJO. Just scanning down here for the past month, you can see most of the numbers are positive. The 30-day average takes the guesswork out of it. The value today is 6.20. But you see we were up at 11.5 or something like that back in October. If anything, maybe we're in a weak active phase of the MJO. But we know that's not true because the inactive phase is in control right now. That's actually a good sign. That also sort of hints that maybe La Nina doesn't have as good a grip on the atmosphere as you would think it does looking at the subsurface temperature data. And then, of course, the 90-day average today at 8.31. Still positive, but not, that's where it's been. We were 9.55, but a year ago, we were, I think, in the plus 15 range, something like that. So not so bad. And the 30-day average, I think at one point got to plus 19, something like that. In fact, let's go look at a graph. So here we go, 30-day moving SOI graphed out. Let's go to, well, here's where we are today, right here. The downward movements are the active phase of the MJO. The upward movements are the inactive phase. And let's go back. January 2019, we were in a weak El Nino. You can see all negative values there. In January 2020, you can see slowly creeping up. The inactive phases were stronger than the active phases, so the balance moved towards La Nina, high pressure building in the Pacific Ocean. Our peak, it was 20.5 per this index. January of last year. And then this summer, things almost fell to neutral. Now we're back on this kind of upward, you can see the steady upward climb here. But today, not so bad. A little bit of a active phase of the MJO pushing us down. We'll see where we go. Oh, and we are, November? So where were we in November? July, August, September, October, November. Last year, we were exactly where we are this year and falling the same way. And then we got into December and it was a steady uphill climb from there. So right now, La Niña looks to be about on track with where we were last year at this time period. So finally, where are we going? What do the models say is going to happen? All right, this is data from the CFS version 2 model. Sea surface temperature anomalies for the Niña 3.4 region. Today, where are we? November temperatures, about 1 degree below normal. That's about right. Falling. Now this model, I think we were up at minus 1.75 degrees last week. Now saying temperatures falling down to 2 degrees. And they were supposed to peak out at the end of November. Now it's pushed it out for this model till mid-January. These lines, this isn't the beginning of January, this is the middle of January. And then a quick recovery from there to neutral. So we'll see. This is sort of the raw, wild data. This PDF corrected version is probably closer to what NOAA considers their official forecast. It says temperatures peaking out in November. Let's see, well, that's mid-October. Mid-November would that'd be about mid-December. So later, again, pushing it out into January and down but 1.5 degrees below normal. That's, I think last year, I don't remember what we got to, minus 1.8, something like that. So about like last year, according to this model. We'll see what really happens. It seems decidedly, with things being the way they are, well, in fact, let's just talk about it for a second. So for right now, not a whole lot in the ocean in terms of swell production. No major gales on the charts at the moment. A series of weak gales forecast for this week. Maybe a little bit better a week out. But still, La Niña pretty much in control of everything, locking things down. Not only La Niña, but the inactive phase of the MJO as well. So it's the double whammy right now for the next 2 weeks, something like that. We'll have to suffer through it. I think as we get closer to Thanksgiving, that pattern might let up a little bit. But the interesting part is the core of the La Niña cold waters are westward displaced a little bit, suggesting maybe La Niña maybe won't be as strong as the models suggest it is. I mean, the models are best guess, and we're still 2 months out from where this thing is supposed to peak out. So we'll just have to watch it, but just sort of guessing. I don't think things will be any worse than they were last year. And I think the added bonuses with the core of the high pressure bias and the core of La Niña being westward displaced more towards the dateline. Again, that opens up the door for precipitation into California. Will we get a normal precipitation amount for this year? Probably not. But if we get 75%, that would be a lot better. Last year, I think we got 42% of normal precipitation. So 75% would be almost double that. So again, take what you can get. The reservoirs, not particularly full. They're pretty well drained, but, every drop counts. All right, so for now, we got to suffer through 2 weeks. There is some little southern hemi swell coming for Southern California, and wind swell and other sorts of swell for Northern California and Hawaii. Looks possible. All right, if you enjoyed the video, where is it? There we go. Give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. If you don't want to subscribe, that's okay. Go to stormsurf.com. We post the link to the video at the top of every page of the site once we get the video all put together and posted, and that'll be in just a little bit after we finish doing this here. And then comments, always welcome. If you have questions, I know this is very deep. It goes on for 45 minutes. It's a lot of data to absorb, but again, people have come up to me and go, I keep watching the video, and a little bit at a time now, after like 9 months or a year, it's starting to make sense. And you know what? It's taken me a long time too. So we're all kind of on the journey together. I'm just trying to share what I know with you so that we can all sort of get a better feeling for what's coming in the future. And hopefully an El Nino with a bunch of precip and a bunch of big surf is on the way. All right, so that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.